Hey friends, this is Miss Regine from SOAR Educational Services, and today I want to go over some function notation and work with functions with you guys. This is something you might see in Algebra 2 class. Right here, you have been given a function, and all the direction says is, and let me read that carefully, it says evaluate each function for the given value. That's all it says. So the first one you probably have done even when you were in middle school, sixth grade or so. All you have to do is plug in where you see x, you're going to plug in 4. So this is our original equation where I see x, I plug in 4, because all this notation means is that I'm going to be substituting whatever numbers in that parentheses for x. So you got to use PEMDAS. So 7 times 4 is 28. And then 5 minus 28 is negative 23. So that's our answer here. Now this one is where we're really getting to our Algebra 2 skills. You're still doing the same thing though. So you have your original equation, and wherever you see x, you're going to plug in x plus 3. You're still doing PEMDAS, so we multiply first. Negative 7 times x is negative 7x. Negative 7 times 21 is negative 21. Now we can add or subtract, but we can only combine things that are alike, so we're going to combine like term. So we have 5 minus 21 is negative 16 minus 7x. Okay, and then the next one, f of negative x. This one actually, it's useful if you're trying to figure out if something is an odd or even function, because if it's an odd function and you plug in f of negative x, you're going to get the same answer, but everything is a negative version of it. But if it's a positive function and you plug in f of negative x, you end up getting the exact same answer. And if it's neither, then we won't really see anything. So let's try this. So I'm going to plug in negative x. So, oops, I'm at negative x. So again, we multiply first. Negative 7 times negative x is positive 7x. 5, well, you just bring down the 5. There's nothing to do with the 5. And you can't combine these because they're not like term. So this one is neither, because if it was positive, then we would end up with 5 minus 7x again. And it does happen. If it was negative, we would have ended up with negative 5 plus 7x. But it's neither, because we just ended up with something that is different from, it's not the exact negative version, it's not the exact original. So it's neither. Okay, but let's keep going. Let's try another one like this. So g of x, this one's a little longer. Okay, let's see if you are asked to find g of 0, g of x minus 1, and g of negative x. So it doesn't matter if it says f of x or g of x, it's the same thing. Okay, so g of 0 should be very easy to see. You're just plugging in 0 into here. 0 to the second power is 0. 0 times 3 is 0. Minus 5 times 0, which is 0, plus 2. So in this one, it's 2. By the way, that's also your y-intercept. When x equals 0, y is 2. This one, let's plug in. Where we see x, we're going to plug in x minus 1. So, yeah, this one will be a complicated one. You can pause the video and try it on your own first and see how you do. All right, so x minus 1, we got to do, so think about parentheses, PEMDAS, parentheses, exponent. I see an exponent here, so I got to do that one first. So I got a FOIL. So we got a FOIL. So this is what we have. X squared minus 2x plus 1. In the interest of time, I'm just going to also do the multiplication here too. So minus time and space, minus 5x plus 5 plus 2. Now let me distribute this 3x squared minus 6x plus 3 minus 5x plus 5 plus 2. Now we can combine like terms. So I see minus 6x minus 5x. Okay, yeah. I think we're good. So we have 3x squared, which had nothing like it. Negative 6 minus 5 is negative 11x. 3 plus 5 is 8 plus 2 is 10. So that's what this gives us. Okay, so I'm going to need to erase that to try the next one, which is the g of negative x. Remember, we can see if this is an odd or even function by what this does. So 3, where I see x, I'm going to put in negative x to the second power minus 5. And I'm going to put in negative x plus 2. So negative x to the second power will just give me x to the second power, which is 3x squared again. So think about that. Negative 1 to the second power is positive 1, and then you have your x. And then I just distributed the 3. Okay, here, negative x times negative 5 is plus 5x. And then we have our plus 2. So this would have been an even function. Oh, actually, no, it's not an even function, because here my sign changed. But the other, so it's neither again. Okay, so that's how we would do this one. But all you have to, you actually didn't have to answer whether it's odd or even. This one was just evaluating the function for the given value. Okay, so here's another one. So again, in Algebra 2, you're often given these different scenarios where they say, use this equation if x is greater than or equal to 4. But now use this equation, or this function, if x is less than 4. And then we're asked to solve for g of 13, g of 0, and g of negative 3. Okay, so g of 13 is greater than 4. So where I see x, I'm going to plug in 13. So 13 minus 4, which is 9, and the square root of 9 is 3. Okay, so that was pretty easy. Now let's plug in 0. Well, 0 is less than 4, so we're going to use that bottom one. 4 minus 0 is 4. And g of negative 3, that is also less than 4. So we'll use the bottom one, 4 minus negative 3, which is 7. If they gave us 4, we would have to use the top one. So it would be 4 minus 4 is 0, and then the square root is 0, 0. And these are also very interesting when you look. I'm not going to make the graph for you today, but these are also interesting when you look at the graph and how you would graph it. Anything that falls here, well, at the end, you would have to have a closed circle because it's x is greater than or equal to 4. So you would have to do a closed circle at that end point where it's 4. And this one would be an open circle at the 4. So it's just interesting to see the overlap. Okay, here's another one like that. So we have f of x equals x squared minus 1. And I think it's over x minus 1 if x is not equal to 1. And then it's just 12 if x is equal to 1. Those are also very interesting. Okay, so f of negative 2. Well, that is not equal to 1, so my answer is 12. And that's it. So it looks complicated. It looks like they're going to actually do something crazy, but that's it. If f is equal to 1. Oh, I'm sorry. That one is 12. This one we actually have to plug in for a. So if x is not equal to 1, we use a top equation. Okay, so let's use the top equation, but it's still not going to be crazy. Negative 2 squared minus 1, negative 2 minus 1. Okay, so x is negative 2. So if we take negative 2 to the second power, we have 4. And for the bottom one, negative 2 minus 1 is negative 3. 4 minus 1 is 3. 3 to the negative 3 is negative 1. So that's it. So we did have to plug in because we're choosing, it says if x is not equal to 1. So negative 2 is not equal to 1. So we're just going to use that top equation, plug it in. You have 4 minus 1, which is 3. And then negative 2 minus 1, which is negative 3. 3 over negative 3 is negative 1. Now this one, where x is equal to 1, then that's just 12 because that's just it. Now this one again, it's not equal to 1, so we're going to use the top equation. So 2 squared minus 1 and 2 minus 1. So 2 squared minus 1 is 4 minus 1. And we have 2 minus 1, which is 1. 4 minus 1 is 3. And we have 3 for that one. So that's how you would do these equations. And often, yeah, you do have to graph these two. So it's always interesting to see how they look like when they are graphed. Okay, so we will stop here for today. I hope this was helpful. Remember to like and subscribe if you learned something today. And I'll see you next time. Bye.